thank you for registering and joining us for the Team Bounders community. So, talking about Team Bounders is an online platform for tech-savvy individuals like us, and we are a team of highly skilled bug hunters. And basically, like we strive to come together and learn from each other. So, we tend to provide our members with the latest information and resources related to the technology and ethical hacking. And without further wasting any time, I'm delighted to hand over this session to the speaker, today's speaker, that is Vedant Vayal, who will guide us through the Android hacking session. Hello, Vedant, welcome.
Yeah, thank you, Pratik. So, hi everyone. Am I audible?
Yes.
All right. So, yep. First of all,
Is Vedant audible to everyone else?
I think they have voted.
Yes, it is audible.
Thank you. So, first of all, good morning and thank you again for the joining. I will be sharing my screen. So let me know once it's visible. Okay, can you see it?
Yes.
Okay, all right. Also start the.
Just like before starting, can everyone else just mute their mics? So, like, because we are recording this session, and if you all have any doubts, you all can ask at the end of the session. Thank you.
Or in between, also I will ask you like, do you have any questions, so you can throw them. So, all right, let's start. So, first of all, any of us here have ever been encountered with React Native mobile application? So this, before starting the session, I will tell you like React Native is very, you can say, old as new as compared to mobile convenient mobile Java development. So we'll dive into that. So before, hi, my name is Vedant Vayal. I work as a senior security consultant in Payatu, and you can find me on these handles. So I have worked in InfoSec with over than 4 years. I have experience in mobile and web application pen testing, but from last 2 years I've been keen interest into the mobile application pen testing, and I've been doing a lot of research on the cross-platform applications such as React Native. Starting with React Native, we have had done a research and released an ebook on our Payatu's website, which you can find with this name. I will just paste a link. Also, we have the similar blog on this one, and the same for the we have created two CTF applications to which have based on this contents of the ebook and the blogs, so you can practice your skills on the React Native. So let me just I will paste the links to these in the chat. So this is the ebook. After that, can find the blog, and these are the CTF application. We have developed two CTF application, which you will. We will also be solving some of the challenges from these applications. So these are the applications. So you can check out this. We recently have published this article, and to give a glimpse, this is how it looks like. So this is a 95 pages book. So it's a very much detailed ebook. All right. So let's move ahead with our session. So as Pratik mentioned, I'm the one of the core member of the team Bounters, and we just are like want to have fun while hacking, while breaking the stuff, and also build a strong community as well. So what we're gonna do today is this is our agenda, you can say. We're gonna understand cross-platform applications. So after that we'll dive into React Native applications, and then we'll look into React Native recipe. So this is, you can say, theory part. After that we will dissect React Native application. That means we will be uncovering how a reverse engineering application, React Native application. After that we will hack on React Native application. We'll see some attack surfaces, and there's one special concept in React Native which is called Hermes engine obfuscation, that will be checking out later part of the session. Let me just all right. Anyone have any question? Can you mute? Can you all mute if possible? It's creating a noise. Thank you. All right. So what is the problem with native application? Like native means this Java for the Java application for the Android, and Swift or Swift applications for the iOS. So what is the exact problem with this? Why we can't have the native applications? Why we need to have the cross-platform application? So native application utilizes all possible advantage of the device. So it can utilize all the possible features like camera, all the APIs of the camera, all the features of the microphone, GPS, all the sensors. So native components it can access. So that also, as a result of these things, they render high performance and high efficiency in user experience, but they consume a lot of system resources, like they consume a lot of device resources. But the main issue with these applications are they need to have the two different teams to develop them. So for the Android you need to have the two different one team to develop one native application, and iOS we need to have the another team. So for example, in case of some small e-commerce organization which sells their products online, they do not need to have this massive team of the people to develop these two different applications. And why is that? Because the linear functions of these applications are the same. You don't there is little to no difference between Android and iOS features. You just need to have some UI, you just need to have you have product page and all these things. So it's to having two different teams is a time consuming, you can say, and it's also costly for the small organization. That's why cross-platform applications comes in picture. So cross-platform application can have the same code base and can be used across a platform with slight changes. So for the Android and iOS, even for the Windows or any other BlackBerry devices also, you can have the same code base with a little to none changes in the code base. And also the main benefit of having the cross-platform application is that they can utilize the features of the native components, along with having the lightweight ability to run on the device. So a lot of people mistake for the hybrid and the cross-platform applications. those applications are not same. Hybrid applications are more like web plus native components are there. So you would have the web view kind of element and plus with the native features, but cross platform applications are very different. They have the same code base, they behave same way for the Android and iOS and other platforms as well. So quickly moving on to the React Native. So React Native has been started as a hackathon project by Facebook's internal team in 2013. So it's been a very game changer stuff uh, for the mobile application development community. That allows you to run, JavaScript code inside the mobile environment. So it utilizes a JavaScript ES6 plus based framework along with XML syntax, which is called JSX, that we will see in next slides. So thanks to its feature of reusing large chunk of code across different platforms, you just have to code once and run everywhere. So you can have one team for the mobile application development, and you can deploy the applications on the different platforms like Android and iOS. And what is the native? What is a native in the React Native term? So native is like the native features or the native components that we can use. So the merging React.js and native components, we have the React Native platform. So as I told you, we can utilize the JavaScript plus XML that gives us the React Native. So it's a mixture of JavaScript core logic and XML layout logic, and we have the React Native application. All right. So moving forward, all right, you can see a React Native applications are written in JavaScript plus JSX, which I already described. So this is the basic syntax of the JSX component that we discuss. So as you can see, we return the logic and the layout in the same file. So React Native consists of different components. So think it like as an activity of the Java. React Native works on the component level. That means we can have a different components, but their layout files also, layout logic or layout, you can say schema, will be in the same file. So we don't have to create a different layout file for the different activities, unlike our conventional Android Java development. So with the React, you can have the full access of the native platform features. You can access the camera APIs, you can access all the sensors while having your application developed in the JavaScript. So as I mentioned earlier, React Native has been there for like 9 to 10 years now, and the community of the React Native is very huge. You have the numerous npm packages for all of the your functionality. You will find most of the these packages online on npm.js. So React versus React Native means React.js is used to develop UI components for the web application, while React Native is used for developing entirely mobile applications. So this is basic overview, like how JS code gets translated into native code of the platform. For example, we write code in JS plus JSX, right? Then there's a concept of bridge, which handles the communication between JS and the native component, and the JS gets converted into a native code of a platform. So this is very basic overlook of the how these React Native applications work. We'll go in much deeper of these things. So this is the behind the scenes, as you can see. So as you can see, this is the React, right? So React is basically single threaded. So if one component is being loaded or being rendered, another have to wait in line to get that first component complete its process or rendering. So this can have the significant performance issue. Also, the efficiency of the application gets reduced. So to tackle this issue, React Native have developed a concept of multi-threading. That means we can have the multiple threads, multiple processes running, multiple components being rendering parallelly. So in contrast to this React native applications like Java or the Swift applications, they work synchronously. So they use the concept of multi-threading and they render their components in parallel. So for now, understand the flow. So this is the React framework. We write a JavaScript code in a React framework. All right. So this is JavaScript code which gets sent to the JavaScript core engine. So this engine plays very important role for the for it converts the JavaScript code into the native code. It handles these things. And the bridge concept that we talked about, it just handles communication between JavaScript and native code. So whatever the instruction which has been provided by JavaScript core engine is sent to the bridge. Bridge creates the threads, and these after that these threads would be sent to the native components, and it also receives the communication or the instruction from the native. So it's a vice versa process. All right, so this is the bridge like we talked about. So it's provides a literal bridge between the JS thread and the native thread. So in simple terms, we write a code in React Native in JavaScript, but which has to be rendered in the native like component or native like code in the respective device like Android and iOS. So for that, as we talked about the threads before that, there are two realms, or you can say there are two environments in React Native applications. First is JavaScript realm and second is native realm. So in JavaScript realm, all the JavaScript related code logic building and this JavaScript to native code conversion takes place. And in native realm, all of the native components of the device like camera, APIs and sensors and all these things plays part in between. And as we talked about, there are multiple threads. So these are the three main types of threads in React Native. So first one is a native, which is a main thread. So this also called as a UI thread because this is the only thread which makes the changes to the UI of the application. So it receives the instruction from the shadow thread. So what is the shadow thread? It is a background thread which executes the operation like what it executes the calculation of the layout, whatever the layout we have defined in our React Native framework. It calculates and pass to the application interface, and then this main thread will receive that calculation and will render the UI or the layout. And the JavaScript thread, this thread has the core logic of the application. This thread has the working logic of the application. For example, in Java we have the class file, right? Activity class file. In that file we write the core logic, and in the layout file we write the layout or how the component would be shown on that screen. So as you can see, you can say JavaScript thread passes the information via bridge to the shadow thread, and the shadow thread calculates all these things and send to the main thread for the rendering on the UI. So as I told you, this is the sample React Native project structure. One minute. Okay, it's working fine. So as you can see, this is the sample React Native project structure. So if you were able to develop the application in Visual Studio Code, they have the some plugins and some components preloaded for you. But for now, just focus on these components. As you can see here, Uh, as I talked about the activities or the components, these are the components. These are the separate components, just like the Android Java classes. And this is the main component, app.js. And you can see this is very weird looking code structure, which has JavaScript also, which has XML also, which has some part of HTML also. So this is very complicated, but it's not very complicated once you get to know about it. It's not very complicated, and it's very fun thing to develop. So what happens actually when you compile this project into an APK file, like how we do in Android Studio? We compile means we combine all of these activities into the one single APK file. So what happens in that case? These classes file gets combined into classes.dex file, right, in case of Android, and layout files will be in the resource folder. But in case of React Native, all of these component files and all of these other supporting files would be bundled into one single file, which is called index.android.bundle. So literally this happens. All of these components, all of these subcomponents, and this is the main component, this gets embedded into one single file, which is called index.android.bundle. And I'm talking very highly of this bundle file because it's very important in case of this React Native applications. So this is what we have learned from last 10 to 15 minutes. This is the, you can say, React Native code. We can say JS plus JSX code written during the development on the React Native framework, which is sent to the JavaScript core engine, which convert JS code into respective native code, right? Native code of Android or iOS. With the help of a bridge, it communicates between React Native and the native code. And the bridge facilitates communication between these two components, JavaScript code and the native components. And finally, whatever the native code has been converted, it gets sent to the Android and iOS platforms, and it will be run on the respective platforms. Also, it provides a support for all the native features such as this camera access, sensors, lenses, and device information, etc. All right. So, anyone have any question until this? After that, we'll be looking into the React Native applications. All right, so I think I take this as a no. Let's move ahead. So we'll be reversing React Native application. So as I told you, we have developed some CTF applications. So we'll be doing our tests on these applications only. So you can decompile with, as usual, APK tool, or you can do a direct unzipping, which is both are the conventional methods, just to mention. Okay, let's do it. I have the APK. So these are the two APKs, CTF APKs that we have developed. Let me just put this here. Okay. So as you can see, we have the React Native, but just let's first install it before reversing or decompiling it. Let's install it on our device here. Let's see what are these applications. So this is the first one, is vulnerable RN. It's just a basic without Hermes APK, and this has been embedded with Hermes, so that Hermes will see in next upcoming slides. So this is our application which has been installed, and as you can see, this is the application, and we have this set of challenges. There are a lot of challenges you can play with, and all of this has been demonstrated in our ebook, so you can check that out later. So this is the application, right? After that, if you want to, we will just reverse it. We'll just decompile the application with APK tool. All right, we have the folder, and this is the file structure. So let's understand the file structure now. This is the file structure of the React Native application. As you can see, there is an asset folder and all other similar folders as Java applications. But the interesting thing is here, under the asset folder, there is an index.android.bundle file, and other resource files will be there, like SSL certificate or any image file or any other supporting components will be there. But main thing to focus is this index.android.bundle file. All right. So this is how it looks like during the development, and this is how it looks like after you decompile it. So let's see how the bundle file looks like. All right, emulator is this. I'll prefer Android Studio's emulator AVD over the Genymotion, because Genymotion lags a lot and also have some dependency issues. Alright, so this is our index.android.bundle file, and why I'm talking highly of this file, because all of the logic of the application, all of the entire logic of the application would be inside this file. And you can see this is very messy file. You cannot make anything out of it. So let's just beautify this file, because this is in minified format. Let's just beautify it. Okay, let's just copy paste back. So here's a tip for you. If you have ever encountered this React Native application and the bundle file, whatever the user has wrote, whatever the user or developer has wrote, whatever the code developer has wrote will be always at the end of the file. Right, just go to the end of the file, and for example, we will have to search with the keywords. For example, let's go to this first challenge. You can see this is hard-coded secret. So what we'll do, we'll search for some keywords like hard-coded. So you can see this is the element that we have created. So it's very complicated to understand. You have to have the basic knowledge of how bundles work, how JavaScript works. So before moving to that, let's understand this bundle file. So this file, you can say it's the heart and soul of the React Native applications. It contains entire logic of the application, and it is a JavaScript bundle file, and all of the application JSX code is compiled into this minified format. So whatever challenges or whatever things we would be doing would be playing around with this file only. Okay, all right. So these are two challenges that we have developed. So you can find these in the links that I provided. So let's have our first demo. First, we have decompiled the React Native application, right? This is our decompiled folder. Inside, there are some hard-coded secrets. So let's go to the assets folder in this index that Android.bundle that we already opened. Let's search for some keywords like hard-coded. As you can see, we have our first flag, which is for the hard-coded secret challenge. You can also search with different keywords like secret. As you can see, there is also some secrets or some logic that should not be there. And also one thing to note, whatever the npm packages the developer uses, that may also have some hard-coded secrets. So who knows, you might get CV for those packages also. You can search for those also. And the main thing to note in case of React Native is it's very convenient to hard-code these secrets instead of just dynamically fetching or encrypting it. Most of the time, React Native developers will hard-code the API keys, tokens, or password. You will find a lot of this in this one. So this is our first flag, you can say. This is our first challenge. It's very simple. This is designed to just to let you understand the logic of this index.bundle file. Moving on to the next challenge is modifying applications logic. All right, let's have a demo. So what this actually means, we have the first challenge here, breaking logic. All right, and what the challenge describes is make the counter value equal to 1337 to get the flag, right? So this is the counter value, and if we have the button, if we try to increase it, it will be increased by 5. All right, it will be increased by 5, so it's not possible to get to the 1337 value. Let's again open the challenge. As you can see, it's not possible to get to the 1337. What should we do? We have to find the function that has been assigned to this button, and we have to see what is the logic behind this. We have to there are 2-3 possibilities here that we can assume. First one is this button can only increase the counter value by 5, or there has been some setting or there has been some logic which checks whether the counter value is equal to 1337 or not. So either we can change this counter value, or either we can change this 1337 value to some increment of 5, like 1340. So let's see. We already have decompiled the application. We already have decompiled the application, right? This vulnerable RN. Let's go to asset folder. Let's go to index.and.bundle folder, and let's try to search this button. We'll search it by its value, like saying increase, so it's text value. We'll try to search. As you can see, there's one increase text, you can say increase element that has been created, and if you scroll above, you can see the onPress function. All right, so this is the function of the button, because it also has this counter value above it, and the counter value has some variable. So this is in minified format, so it's very hard to keep up, but you will eventually pick up the pace once you pen test the React Native applications. So this is the challenge description, as we can see. So that means we have found the code block that we've been looking for. Just a minute. Okay, so as you can see, this is the logic. So this is the logic of the button. This increases the button value by 5, and also it checks the possibility whether the button value or the counter value is equal to 1337 or 136. So let's do one thing. Let's change this value to 1, so that counter will increase. This counter will increase by 1, not 5. So we have changed value from 5 to 1, and now we just have to recompile the application again. So let's do that with our apk tool. This is the command to apk tool b, that means build, in our application folder. First of all, let's uninstall this application. It's taking a lot of time actually. Okay, yeah, how to root AVD. So you will find how to root AVD in the playlist provided in the Team Mounters YouTube channel. So you can check that out. It's really simple with the Magix module. You can check out. It's really easy to build the Magix RAM disk and root the device. So the application has been built. Let's go to the application folder. So if you have idea about the APK tool, it creates a new APK inside the dist folder. Alright. So I'll show you also. So this is the decompiled folder. In the dist, it will create the new APK. But if you try to install this APK, it will not work. It will give the certificate error because we have to sign the application. So let's create the self-signed certificate, and for that we have to create the self-signed certificate with this key tool. So this is very simple example, which is also we have mentioned how to do it in our ebook. So let's create one key store file. Okay, we have created our key store file, right? And what now we have to sign our application with our self-signed certificate. For that, this is the command. This is a jar signers command we can use to sign the application. Here we have to give our key store files a name. After that, application name. After that, alias of key store file, which is basically this thing only. After that, we have to provide what password we use, and yeah, our application is ready. Let's try to install it. Okay, it has been installed. Let's go to our challenge again, and this time you can see the counter value is increasing by 1, so we can reach to 1337 easily, and we have our flag. So what we did in summary, we just found that counter value is increasing by 5, so we change the incremental value to the 1 so that we can reach to 1337. So you would say like this is very simple example, but this kind of logics or this kind of implementation you will be seeing in the React Native applications. Just a minute. Yes, we can bypass root and SSL pinning in React Native with both. You can bypass it with Frida itself, with Frida's conventional way. But if you want to, bypass the root detection and SSL pinning, by modifying the application's code, like how we modify the Smalley code of the Android Java, you can do that as well. That we have. You can find that challenge description, and you can find that in this ebook also. Let's see, we can have that demo also. Let's see. But first, moving on from this modifying the React Native, there's one special storage which is called async storage, asynchronous storage, which is specifically made or designed for the React Native applications back in 2014 or 15. So it's an unencrypted, asynchronous, persistent key value storage system. So as you can see with these 2-3 keywords, it is not reliable. It is unencrypted, which is also asynchronous. That means it's not reliable and also insecure. All right. So whatever data you store there will be there after logout or even after application restart, right? So even if you remove uninstall the application, the data will be there, so it will not get wiped out, and the data would be stored unencrypted. So if any developer tried to store any session cookies or any kind of token in this async storage, there will be a problem, and you will find a lot of developers do that because it's very easy and convenient. So let's see what exactly this async storage works. Let's open our application, and there is a challenge, async storage. So the challenge description states: store some text in following input field and retrieve the stored text in async storage along with the flag. So we have to store some text, some sensitive information which will be stored unencrypted, and we'll see how to retrieve that data. Let's store some stuff like we'll store this keyword. So this is stored, and this would be stored in the data directory, data package name, database directory of the this applications package. Okay. So without root, the other applications cannot access, because as you know, this is the sandbox directory. That data directory is a sandbox directory. But if the device is rooted, other applications can access that directory. So as you already known about the vulnerability in Java Android, like unencrypted SQLite database, it's similar to that, but it's for the React Native. All right. So what we have did, we have stored some data. Let's retrieve that data. For that, let's go into the device. Let's go into the data directory. Let's find the package name. So this is the package name, our application's package name. Let's go into that. Let's go to the database, and just for your information, this device is rooted, so we can go inside the root directories, and here these two databases you can see, which would be created by default once you store some data in async storage. So let's try to see what's inside them. Okay, so if you do a string, so you can say cat. So basically, if you open this application, this is the stored value. This is the whatever we have stored inside the async storage. Let's do that with this thing only. Strings would be better. So you can even copy this. Where it went? You can copy these two database files, and you can open that with any database viewer in your system. But for now, as you can see, we have retrieved that value. It is getting stored in plain text. So this is just similar to the SQLite database, you can say, but for the React Native, it's the working is little different. This is, you can say, some low-hanging vulnerability in React Native, which would be most of the time would be there. Okay. Anyone have any question until now? You can also type in chat. Okay. Yeah, SQLite 3 is database type. So it is, you can say it is which is used in Android also, which is used in Android only. SQLite 3, you can use it outside Android, but specially designed for the Android applications. All right, so let's move to the Hermes, and it's very, you can say, complicated thing which React Native team has introduced. So basically, if you look at the index.android.bundle file, it will look like this if there is a Hermes obfuscation. So if the team has enabled the Hermes obfuscation, the index.android.bundle file will look like this. It will be obfuscated or encrypted or whatever you have to say. You would not be able to read the data or read the files like how we saw, like how this webpack format. You would not be able to see. Even if you try to retrieve strings from it, there would be no proper strings or data, readable data. So literally, you might wonder like what exactly happens here, why this is all this jargon happened in this bundle file. So let's understand this. So Hermes is an open source JavaScript engine optimized only for the React Native application, and which is used for improved performance, decreased memory usage, smaller app size. But what it does, it converts the this bundle file code into the machine readable format so that it can have all of these advantages. Also to prevent the attacker or to restrict the attacker to some extent from modifying these files. So this minified JS bundle file is now converted into Hermes obfuscation. So you can say Hermes is a, you can say, kryptonite for the pen tester. It's very painful thing to pen test with Hermes obfuscation, but there is a way to convert that mess into human readable format. So there has been a tool developed by this amazing guy. You can find him on the Twitter, which is called HBC tool. So you can say it's a tool against the Hermes obfuscation, which lets us convert the Hermes mess into the human readable bytecode. So note that the code in the bundle file would be converted into bytecode, machine bytecode, but not in the JavaScript code. But at least we can read the file, we can have some sense over it. So you can edit, patch, and patch the bytecode to modify the application logic. First we'll see like what is Hermes bytecode, how to use the HBC tool, and how to discover the secrets inside it. All right. So there's another application. So this is the second challenge that we have developed specifically for the Hermes test case. So let's install the Hermes application first. Let's exit. Okay, there is the APK. db install. Alright, this is our APK. So as you can see, there is nothing changed inside the UI. It looks similar. These are the challenges. It looks similar. Nothing changes in the UI. But let's decompile the application with APK tool. Okay, so let's go into the this bundle file of this application, and you will see, as we seen earlier, it's a mess. You cannot read it. So the HBC tool, with the HBC tool, you can convert this file into bytecode. So how to install and all these things, you will find how to install the HBC tool. You will find, you will find all these things in this GitHub repo. Let me also paste that here. Sorry. So let's use that tool. For that, we have to go inside the application folder, assets folder. Assets folder, and there is this bundle file. Let's see our tool works here or not. Okay, let's run that tool inside our Kali, because I'm having some restriction on my company's laptop. So now we will run it inside our Kali system. So here you can this is actually the shared folder. This is actually the shared folder between this Windows OS, host OS, and this guest OS. So whatever the files would be, all of the files would be same. Let's open the terminal again. Let's go inside the Hermes CTF assets folder, and let's open the terminal here. And let's see tool works here or not. Yeah, we can use the tool. So the syntax to deassemble the code is dsm. Then we have to give the bundle file. Then we have to give the output folder name, which I'm giving this output X. So it's disassembling the bytecode. And here you can see the bytecode version is 84. Currently, the React Native team have released the bytecode, this SBC version to 89. So if there's a very low hanging fruit, you can report this vulnerability if you found that SBC version is not greater than 89 or is equal to 89. You can report that. Okay, let's go back to our disassembled directory, and you can see this is the output X folder. Inside you can find 3 files. So there is a function of a 3 file. First of all, these 2 files we have been key users to. This metadata.json does not have much information. It's just a mapping file. You just map these 2 files. So you'll find there is nothing but just a mapping information. But interesting enough, this string.json file will have all of the strings of the bundle file. All of the strings would be, you can find inside the string file, right? For example, in case of Android, you will find the all of the strings that developer have hard coded inside the values strings.xml file in resources folder. Similarly, you can find the string.json, whatever the strings has been inside the bundle file, we will find in string.json file. And in the instruction file, here lies the core logic of the application. So as you can see the registers and the functions and the load constants, and so this mimics the machine bytecode. So now, as you can see, the things now got escalated to very advanced level. Once the Hermes is involved, all these things would be very, very much harder. But there is a way, there's still way to bypass all these checks and read all this core applications logic. For instance, we have seen what is the Hermes bytecode. Let's open first challenge, which is hard-coded secret. Okay, and similarly we have to find hard-coded secrets in the application. So let's go to the string.json and try to find with the similar keywords like secret. Okay, secret, you will find this is the string that we will be saying in the challenge, and this is the flag which has been hard coded. So developers might also hard code keys, tokens similar to the non-Hermes APK, and you can find these strings also inside this instructions file also, because whatever the strings are there, like this window or this global, this you can find inside the strings.json. So if you try to find a secret also inside this one also instruction file, you'll find there as well. But there is much, if you are only interested into the strings, this file will be sophisticated for you. So this is our flag that we have gotten, and we are also developing one portal to submit these flags that is still under the development so that you can validate the flags value. And for now these flags are hard coded, but for some challenges some flags would be dynamic, so that the flag would be unique to you only and any instance only. And going on to the second challenge, we'll solve the second challenge also. So here's the challenge states breaking log. It's really exactly similar to what we have seen in the non-Hermes APK. So here we have to change the counter value to 1337 to get the flag, and it similarly blocks our way by increasing the counter value to 5. So it's again impossible to reach to 1337 with this. So what we can do, we can decompile the application. After that we converted the Hermes code into the human readable format in this instruction file with the HPC tool, and then we will try to find this function. So now it's very messy to find this function, but I will help you with that. For example, we'll try to find the same with the same keyword, like this increase. Okay. So there is one keyword. So there might be multiple keywords also, but keywords with the same name increase. But what you have to see in case of the button, you have to find the on press. You have to find the on press just above your string, right? So as you can see, this is a string, which is a string, and this is the function. So this create closure called as a function. So I know this is very complicated, but in the ebook we have mentioned the like how to read the code, how to navigate through the code. You will find it. Just a minute. In the section of understanding Hermes bytecode, you will see what are these function, what are these stands for, how to identify, how to navigate through functions, all these things. So we have the on-press value. Now we have to find the function. This is just a declaration. We have to find the function. So this is the function value. This is the function value, and we have to find the function with this. So this is a floating button. As you can see, this is the touchable opacity we have given, and we have created an element. And above that, you will find the counter value. Alright. So we copied the create closure. The create closures means this is the function. This is the function they have declared, and this is the code of the function. Let's search for that, and you have to find it like this one only. So this will be the syntax of the function. This is the function, this is the function name, and this is the function's value or the machine bytecode value. So this is, as you can see, it is an increment counter, which as a name suggests, it increments the counter. So here let's understand. As we see inside the for now, let's open the let's open the our non-Hermes challenge, and I will show you by comparing it. So here on press function, it's either checking value is 1337 or 1336, and it's increasing by 1. Earlier it was 5 as per challenge. And here also you will see this is the integer value which is increasing by 5. All right, this is the comparison factor. This is the comparison value, load constant integer. These two values 1336 and 1337, as you can see. But this time, instead of changing the counter value to 5 to 1, what we'll do, we'll be changing the 1337 value to increment of 5 itself. For example, let's change it to 1345. Okay, and this to 1344. It is not necessary to change this value, but we'll do it for the safer side. So we have changed to 13345. That means if we reach to 1345, we should get a flag. So let's just save this file. Now we have to build the Hermes code again. We have to assemble the Hermes code again. So as we disassemble it, let's assemble it with this command, assemble. Now we have to give the output folder name where all of these 3 files would be there, these 3 files. Along with that, index.bundle files. So this tool, what will do, whatever the things we have done, whatever things inside this, it will rewrite these things inside the bundle file. So it will be as it is, but our little change of values. If you assemble it, after that, yep, it's done. Now as usual, we will build the application. Let's go back. Let's build the application with APK tool, build this one. Let's uninstall the application again so that we can install the new application. Okay, what could go wrong if our Hermes version code is older one? Basically, basically any user can convert this code into human readable form that we have been doing. That means this HBC tools is also evolving as this Hermes version is also evolving. But it's better to have the latest Hermes version because for the 89 version there is no this HBC tool do not support the 89 bytecode conversion till now, but in future the bypass will come. But again the React Native team will again release a new version of the bytecode, like let's say Hermes 90. So it's just a cat and mouse chase between this React Native Hermes and HPC tool. Okay, our application has been built. Let's go inside the folder and let's go inside the assets folder. Sorry, let's go inside the dist folder where our application has been built. And similarly, we have to again create our custom key store. Take the password. This thing, whatever you can provide, doesn't matter. Now we have to sign the application. Okay, let's sign it. This is the key store name. Oh, sorry. Our APK file and the alias. Okay, now let's try to install it. And it be install our APK. Okay, let's open the challenge and let's see what happens if we increase it. It increasing as usual by increment of 5. But if we go beyond 1, 3, 4, 5, we'll get the flag. So this is the way to break the Hermes or do changes in Hermes also. There is another challenge which is even harder than this one. In this one, we'll not be solving this challenge. We'll keep it for you guys to solve it. But basically, you just have to assign the function, the correct function in this button so that it will alert the flag. Alright, so you will find what is the correct function inside the code itself by following the trails. But for now, there are these two challenges we have developed. You can definitely check them out. And someone was asking how to route AVD, right? So you can route that with Magisk module also. There is a let me see. Okay. So one of my friends from the path who have developed a script to root the device with one click only. You just have to install these scripts. You just have to download the zip and you just have to run the script. It will automatically root your device. You just have to keep your device running. So I'll just paste that link in chat. You can check that out. Or even if in case if you want to root your device, I have the proper guide. This is the simplest way. Does this work on Mac M1 chip? I didn't understood this. I think it's for the Windows only for now. So there you can either Windows or maybe Linux. I'm not sure. Yeah, it's for the Linux maybe, but I have only used for the Windows also. Windows only. So not sure about the Mac or Linux Unix system basically. So I think that's about it. We have concluded the session. So the React Native is very, you'll say, very new framework for now as well, because a lot of people get confused between these things, and because of the this messy code, the Hermes async storage and all these things, it gets very confusing. So do you have any questions, anyone?
So, hi Vedant, this is Vinesh.
Yeah, hi Vinesh.
So I saw there was in index.android.bundle there was a process.env. So
Where?
can you open that?
Where?
In index.bundle and non-Harman code.
Okay, non-Harman. This one only.
So can you search for process.env there?
Okay.
So how you are seeing this, like in React we usually store some credentials like in process.env. So how this can be exposed, or how you are like considering this as a security aspect means?
Okay, you were saying React or React Native?
I actually noticed this in React, but it might be chances that it might be used in React Native as well. So as we can see, right, it's used process.env.
Okay. I have checked a lot of React Native applications, like real world applications, but I have not seen any credentials in this environment. We can say environment files maybe, but I don't have that much of knowledge of the development of the React Native, so cannot tell.
Okay.
Also, let me just I have one application which is called Donald Datus, which is real world application. Let me see if I have that or not. What is that? Okay. So this is the real world application called Donald Datus, and in that, as I mentioned, there's this bundle file, and in that bundle file, they have hard coded some secrets that I mentioned, like Firebase secrets. I think they have hard coded. Maybe let's search the key. They have some URL, I think. Okay, similar to this one, this WebSocket. They have hardcoded some Firebase things also. Sure, where is that? Nope, I cannot find it right now, but they have hard coded. I have seen it. Just I forgot what the correct syntax was.
Okay, okay.
So, have you, sorry, Vinesh, right? So, have you
Yes.
developed the React Native application?
No, I haven't developed React Native, but I have developed the React. So where
Okay, okay.
we were exploring some credentials like as you mentioned Firebase and all.
Hmm. Okay, okay, okay.
Yeah.
So,
So I was
where you would be storing in the environment file?
.env is the file we used
Uh-huh.
to store there. Yeah, and it is basically the some confidential file means that means we don't mention in the Git or source code.
Okay.
Yeah, at the time of deployment only we use that.
Okay, okay. So I will.
So
Thanks for
so
the.
yeah, so like I was thinking like how it is handled in the mobile applications and it's in everything it goes into the client, right? So how it is been managed at the client level.
Actually, whatever I've done in this React Native, like I learned the React Native development. I have not seen the usage of this file. Like most of the time, developer do not maybe store that in the environment file, unlike the React JS. So really not sure whether they are storing there or not, but I will try to do more research on it. Thanks for the information. I will try to search for it, like whether we can have any secrets in that file also or not.
Yeah. Okay. Yeah. And what will be like next, talk or about from the team bouncers and like when will it be in case you are all planning?
That I think Pratik would be better.
Yeah.
Better.
We will be posting that regularly on our Twitter. So I would let everyone know to make sure you follow our Twitter respectively. So for the upcoming session or talk, so you get the regular updates. Any other questions, guys, for Vedant?
So Pratik, it would be like from follow, like can we suggest or like it will be totally from your side, like that?
Yes, suggestions are always welcome. And like if majority people fall on the same topic or same discussion, we can conduct a session on that as well.
Okay, thank you.
So since because of that, like we have a Discord group right now, right? So everyone can decide on the topic and let us know as well. So any other questions, guys? Okay, I guess no more questions. So thanks everyone for joining the session. And Vedant, it was great, knowledgeable session as well. And I hope everyone learned about React Native, hacking into React Native applications. Thanks everyone.
Yep. Thank you. You've been great audience. Thank you.
Yeah, and looking forward for everyone into the next session. Bye bye.
Yes. Bye. Bye, guys.